Problem sheet 6, question 2. Consider the following transportation problem with 4 sources A, B, C and D and 4 destinations W, X, Y and Z. How many basic and non-basic variables does this problem have? So we know that for transportation problem, a basic feasible solution with M sources and N destinations will have M plus N minus 1 basic variables, and the rest will be non-basic variables. In this problem, there are 4 sources and 4 destinations, so we would expect 7 basic variables, and the rest will be non-basic variables. There are 4 times 4, which is 16 variables, and so 16 minus 7, 9 non-basic variables. B. Find a feasible solution using the northwest corner method. What would be the cost of using this solution? So in the northwest corner method, we fill as much as we can into the northwest corner, the top left corner, and then we will either move down south or across east and fill up as we go along. Let's start at the northwest corner, AW. What's the most we can fit in there? Well, A can supply up to 5 and W can take up to 7, so we must be able to only put 5 in there. Now this means that the A source is completely saturated and we cannot fit any more in that row. Therefore, we cannot travel east, so we must travel south. So let's travel south to BW. What's the most we can fit in here? Well, B can supply 19. W can only take 7, and it's already taken 5, so it can only take an extra 2. 2 is less than 19, so we will fit 2 in here, and that satisfies the W destination. So we cannot fit any more in that column, so we will travel east to BX. How much can we fit in BX? Well, B can supply 19, but it's already supplying 2 to W, so it can supply an extra 17. But X can only take 13, so we will put 13 in here. That satisfies the X destination. So we cannot fit any more in that column, so we will travel east to BY. Now B can supply 19, but it's already supplying 15, so it can supply an extra 4. And destination Y can receive 11, so 4 is less than 11, so we will put 4 in here, and we satisfy the B source. So we cannot fit any more in that row, so instead of travelling east, we will travel south to CY. C can supply 6, Y can take 11, but it's already receiving 4, so it can take an extra 7. 6 is less than 7, so we will send 6 from C to Y. That satisfies the source C, so we will travel south to DY. D can supply up to 5, Y can receive up to 11, but it's already receiving 10, so it can only receive 1 more. So we'll put 1 in here, and that satisfies the Y column. The only place we can go now is to go east to DZ. D can supply 5, but it's already supplying 1 to Y, so it can supply 4 to Z. Z can only receive 4, so perfect. By putting 4 in here, we satisfy both the D and the Z sources. So this would be a feasible solution using the northwest corner method. There are 7 cells filled in, so we have 7 basic variables. This is a basic feasible solution. What would the cost of using this solution be? Well, we are sending 5 units of goods on a route AW, which costs 6 per unit. So that route will cost us 5 times 6. We're also sending 2 units of goods on a route that costs 1 per unit. That's BW. For BX, we are sending 13 units of goods on a route that costs 14 per unit. BY, we are sending 4 units of goods on a route that costs 7 per unit. CY, we are sending 6 units of goods on a route that costs 8 per unit. dy, we are sending 1 unit of goods on a route that costs 15 per unit. And finally, dz, we are sending 4 units of goods on a route that costs 13 per unit. So the overall cost will be 357. Part C, find a feasible solution using the minimum cost method. What would be the cost of using this solution? So the minimum cost method, we'll do the same as we did with the northwest corner method, fill in as much as we can before moving on to the next cell. However, this time, instead of choosing the northwest corner and moving either east or south where we can, we will choose the route with the least cost, the minimum cost. So the cheapest route here is BW, costing 1 per unit. So we'll fill that up as much as possible. We can only fill that up by 7 as that satisfies the W source. So we can tick this off. And this means we do not now have to consider these 3 cells as that column is already satisfied. So out of the cells that are left, not including those 3 cells, what is the cheapest cost? That would be AZ. We'll fill that up as much as possible. So we can fill that up by 4, which satisfies the Z column. And again, we cannot fit any more in the rest of that column. Out of the 2 columns that are left, the route with the minimum cost would be AX. So we'll fill as much as we can in there. Now, we can only fit 1 more unit in there before satisfying source A, the row, which means from now on we do not have to consider any other cell in that row. Out of the 6 routes that are left, the route with the minimum cost is BY. How much can we fit in there? Well, in the row, we can fit an extra 12, and in the column, an extra 11. So we can only fit 11 in there before satisfying that column. Out of the routes that are left, the one with the minimum cost is CX. So we fit as much as we can in there. We can fit 6 into that, which satisfies the C source. Out of the cells that are left, the route DX is the cheapest, so we fit as much as we can in there, which satisfies the D source. And there's only 1 cell left, and both the column and the row of that cell is missing 1 unit of goods. So we'll stick 1 unit of goods in there. What would be the cost of using this solution? So we'll do the same again. Our cost now, we are sending 1 unit of goods along a route that costs 3 per unit. That's AX. For AZ, we are sending 4 unit of goods along a route that costs 2 unit per unit. BW, we are sending 7 units of goods along a route that costs 1 per unit. BX, we are sending 1 unit of good over a route that costs 14 per unit. BY, we are sending 11 units of goods over a route that costs 7 per unit. CX, we are sending 6 units of goods over a route that costs 9 per unit. And finally, DX, we are sending 5 units of goods over a route that costs 11 per unit. That would result in an overall cost of 218.